These days you constantly hear the same joyful headlines in the news. An Earth twin has been found. A new habitable planet has been discovered. When you read these headlines, you probably assume that we can go there very soon with giant spaceships, or at least directly see the blue oceans and green continents on those planets with our telescopes. However, this is one of the biggest and most dangerous misconceptions of the space age. The truth is, the physical laws of the universe paint us a completely different and much more ruthless picture. But how long would it really take to go to those famous exoplanets right under our noses that we are told are habitable? Furthermore, when we arrived there, would a paradise welcome us where we could take off our helmets and breathe easily, or a hell scorched by deadly radiation storms? In this video, we will explore the mind-bending distances to our closest planetary neighbours in the universe, the harsh physical reality behind the concept of the habitable zone, and what modern space telescopes decipher in invisible worlds. Let us begin if you're ready. Where and at what time are you watching this video right now? Let us meet in the comments. While looking for a new home for humanity in that freezing darkness of the universe, you need to lay the map of distances and star systems in front of you to understand what you are facing. When you turn your eyes outside our solar system, our pale neighbours stand at the centre of that map. The first reality you encounter on this journey is what neighbourhood means on that cold map of space. Proxima Centauri b, known as our galactic next-door neighbour, is a rocky planet rotating in the orbit of the closest star to us in the universe, and it is Earth-sized according to measurements. Its first official discovery was made in 2016 by an international team led by Guillaume Anglada Escude, a researcher at Queen Mary University of London, using European Southern Observatory data, and was published in the journal Nature. However, the word neighbourhood in the context of space is quite a deceptive term. This planet is located exactly 4.24 light-years, meaning about 40 trillion kilometres away from Earth, according to current calculations. You can compare this terrifying distance to a vehicle driving on an endless intercontinental highway. You set out to go to the next city, and the highway stretches so far that even if you press the accelerator to the floor, you have to stay behind the steering wheel for tens of thousands of generations to reach the destination. This is because this distance makes reaching our closest next-door neighbour inaccessible within a biological lifespan. So how much more complex can this cosmic picture get? When you move a little further away, you encounter that famous TRAPPIST-1 system, to which astrobiologists turn their advanced space telescopes with great hopes. This star system was meticulously discovered between 2016 and 2017 by a global research team led by Michael Gillen, an astrophysicist at the University of Liège in Belgium using NASA's Spitzer Space Telescope. In this distant system, which is located exactly 40.66 light-years away from us, 7 Earth-sized rocky planets rotate in orbits very close to each other. You can compare this cramped structure to 7 different pots trying to get warm by lining up side by side around a single, faintly burning stove in the kitchen. Scientists state that according to current thermal calculations, 3 of these 7 planets, and even 4 according to some optimistic climate models, could have habitable conditions. This is the reason why the system is popular in the world of astronomy. Finding so many potential home candidates together around a single star is a rarely seen richness. But the truly striking thing is this: what is the thermodynamic limit that makes these planets habitable? The habitable zone, meaning the Goldilocks zone concept that you frequently encounter in astronomy literature, is a sensitive astrophysical framework that determines how far a planet in orbit needs to be from its own star in order for water to remain in liquid form on its surface. This theory was first put forward in 1959 by Sushu Huang, a researcher at Princeton University, and then it gained its current strict mathematical limits in 1993 by Penn State University astronomer James Casting and his team. You can compare this to positioning relative to giant speakers in a large concert area. If you stand too close to the sound, you go deaf, and if you move too far away, you cannot hear the music at all. So you need to find that perfect distance and stay there. For a yellow star like our own Sun, this ideal limit corresponds to a range of 0.95 to 1.37 astronomical units, according to conservative climate models. Whereas around the colder and dimmer red dwarf stars, this zone narrows down to a range of 0.05 to 0.1 astronomical units, which is dangerously close to the star. Water not evaporating depends on holding tightly to that extremely thin orbital distance. It is exactly at this point that the characteristics of dim red dwarfs, which are the type of star exoplanet hunters encounter most in the universe, come into play. The physical mass of an ordinary red dwarf like Proxima Centauri right under our noses is only between 8% and 12% of the total mass of the Sun that shines above us every day. The fusion energy they produce is so feeble that they emit a glow that is only 0.15% of the total light the Sun radiates into space. You can compare this disproportionate situation to that flickering candlelight burning in a dark room versus a field illuminated by the powerful projectors of a stadium. The reason for this is that these cold stars make up the overwhelming majority of the star population in our galaxy. Therefore, at the centre of our search for habitability lie orbits that depend on the weak heat emitted by these dim stars. The lonely worlds spinning in the freezing corners of the universe fall as thin leaks of light onto the sensitive lenses of our modern space telescopes. As scientists calculate the orbits of the planets and how much heat they receive from their stars, you actually slowly realize how harsh and ruthlessly a cosmic clock ticks. These small worlds stuck around red dwarfs, light years away, whisper to us that finding life in space is not just about distance. So, when you combine these weak star systems that we place at the heart of the search for life with astronomical orbital speeds, what kind of physical picture emerges before you? The resulting outcome is a dizzying cosmic cycle that shatters our perception of time. These planets stuck in very narrow orbits move rapidly, as if they are being tossed around in the vacuum of space, instead of exhibiting a slow and calm rotation. While you're accustomed to the rhythm of seasons and years on Earth, the flow of time reaches a high speed in those distant worlds and changes everything. The first cost of being stuck in this narrow space is seen in the time it takes for the planet to complete its tour around its own sun, meaning the concept of a local year. Due to the operating laws of galactic systems, the closer a planet is to its star, the faster it is compelled to rotate to resist the power of the gravitational force. One full tour in the orbit of the planet Proxima Centauri b is completed in just 11.186 days in Earth days. You can compare this to riding a roller coaster in a giant amusement park. While you're still trying to grasp the scenery, the vehicle returns to its starting point within seconds, and this cycle continues without ever stopping. A whole year for humanity fits into just 1.5 weeks on that planet. So, how does this situation affect surface conditions? Due to this violent rotational speed, biological rhythms like that calm spring or winter on Earth do not function on those worlds. Moreover, these planets often show slight orbital deviations and move closer to or further away from their stars, even if by millimeters. Astrobiologists have to include not only the temperature but also this savage speed that constantly lashes the atmosphere on the surface of the planet into the equation when calculating the possibility of habitability. However, this high-tempo orbit has a much heavier physical toll that it exacts on the planet. The biggest curse of being closer to the star than 0.1 astronomical units, meaning approximately 15 million kilometers, is the astronomical phenomenon known as tidal locking. When the planet approaches its star this much, violent gravitational friction forces slow down the rotational speed of the planet around its own axis and literally break it. You can compare this to a performance put on stage by two talented dancers. One of the partners constantly turns in a way to look at the face of the other, never turns their back, and this perfect lock is not broken until the performance ends. Just like the moon always showing its same face to Earth, the rotational speed of these planets around their own axis becomes synchronous with their orbital speed. As a result, while one hemisphere of the planet is locked to the star and experiences an endless day and constantly increasing heat, the other hemisphere left behind is trapped in an endless dark night. So can this freezing and scorching climate stuck at extremes allow life? Here, in most of those promising potential homes in the sky, the concepts of day and night have disappeared in the sense that you know them. In order to understand how common this freezing and locked scenario that we encounter is on a universal scale, you need to look at the population distribution of the stars in the Milky Way galaxy. The star formation factories in the universe do not produce stars in every size. Some are statistically dominant. If you think of our galaxy as a large metropolis, those magnificent skyscrapers piercing the sky represent G-type yellow stars that are stable and far from radiation storms like our own Sun, and they make up only 7 or 8% of all the buildings. The remaining overwhelming majority of 70 to 75%, on the other hand, is like adjacent slum neighborhoods, with narrow and dangerous streets formed by M-type Red Dwarf stars that are dim, cold, but magnetically quite aggressive. When you look at the sky, you always look for the peaceful copies of our own system, those safe yellow stars. However, statistics prove to us with mathematical certainty what a challenging and harsh architecture the universe has in terms of habitability. The fact that there are so many stars never means that the place is safe. When the scientific world found habitable zones even in these dark and dangerous corners of the galaxy, it was caught up in a great enthusiasm that the loneliness of humanity in the universe would come to an end. If the orbital distance was correct and water could remain in liquid form, then the only thing left to do was to look with the right telescope and find those blue oceans. Theoretical models were working perfectly, and the hopes of astrobiologists were increasing a little more with each new discovery. Stories of new worlds covered with oceans, temperate neighbours, and peaceful orbits decorated the headlines. Nevertheless, when researchers started processing the first clear data of the dispatched space probes and advanced telescopes on their computer screens, they realized that something was going very wrong in this promising picture they had in their hands. When the dark face of these planets, which looked like paradise in theory, was illuminated, a very harsh wall appeared between expectations and reality. When the research team led by astrobiologist Bruce Jakosky brought the findings of NASA's MAVEN space mission down to laboratories on Earth in 2015, we faced one of the most ruthless truths in the history of planetary science. As humanity, we have always looked at the sky throughout history and dreamed of finding friendly and habitable shelters for ourselves. However, those freezing and dark archives of the universe are full of crises and heavy disappointments that destroy our fantasies and fundamentally shake our deep-rooted beliefs. Those large dried-up riverbeds on its surface had deceived us all by reminding you of Earth. In the past, the scientific world assumed that the waters of Mars had merely retreated underground and somehow preserved the remnants of its thick atmosphere. Thus, it was a temperate planet lying dormant beneath the surface. But the facts revealed by Bruce Jakosky and his team with MAVEN data in 2015 were much more terrifying. When the magnetic field in the core of Mars cooled and disappeared, that protective armor of the planet fell. The relentless solar winds that followed had swept that thick atmosphere away into the vacuum of space at a violent speed of exactly 100 grams per second. While the theory that water was safely hidden underground collapsed, it was proven how that once blue water paradise became barren due to the radiation of the star. This discovery bitterly taught all astronomers that in the search for life, it is not enough for the planet to just be at the right distance, but it also desperately needs an internal geological shield. In our other neighbour that is very close to you, the situation was a life and death illusion. Until those exciting early years of the space age, astronomers assumed that Venus, covered with thick clouds, was a perfect Earth twin for life, adorned with temperate oceans and fertile tropical forests. However, when the Mariner and Venera space probes, launched through the joint competition of NASA and the Soviet Space Agency in the 1960s, landed on the planet in person and sent physical data, all hopes were shattered. Venus was actually a hell scorched by an out-of-control greenhouse effect, its atmosphere consisting of toxic sulfuric acid. The temperature on its surface was measured as exactly 470 degrees Celsius, high enough to even melt lead metal. That expected cool tropical paradise dream took its place in the history of science as one of the harshest illusions in the history of space exploration. This crisis was one of the astronomical shocks that first showed us that everything that looks like Earth through a telescope cannot actually be a friendly home. Our obsession with finding life even in this hell of Venus had completely blinded our ability to read data. When the team led by Jane Greaves announced in 2020 that phosphine gas, which is a biological signature of microscopic creatures, was found in the atmosphere of Venus, a great enthusiasm was started in the world. However, this early victory celebration was met with objections in 2020 and 2021 by two separate independent teams, the Ignace Snellen team and Geronimo Villanueva within NASA. As a result of the investigations, it was revealed that this exciting signal originated from an error in the data processing algorithms of the telescopes or a misreading of an ordinary sulfur dioxide molecule. But the desire to find life was so strong that even the most prestigious institutions were deceived by an optical illusion and signed off on a massive disappointment. This embarrassing crisis showed that atmospheric spectroscopy measurements taken from a distance should never be trusted blindly, and that the universe can deceive us at any moment. As if these crises in our own solar system were not enough, our biggest hope in deep space also turned into a biological death trap. Because M-type red dwarf stars live for trillions of years, astrobiologists assumed that these were the most perfect paradises in the universe in terms of the flourishing of biological evolution and the stability of life. Unfortunately, in the 2010s, deep observation and computer modeling conducted by various astrophysical institutions using Hubble Space Telescope data destroyed this long-lived shelter myth. These dim stars were extremely aggressive, especially during their turbulent youth phases lasting billions of years. It was proven that the intense radiation bursts they emitted ruthlessly sterilized the surface of nearby planets around them and destroyed their atmospheres. These long-lived paradises we thought were safe were essentially the most ruthless sterilization ovens of the universe. The scientific world had to accept that these stars, which seem perfect in terms of time, are so dangerous that they would not leave the worlds around them alive even at a microscopic level. Astronomers saw each time that their own expectations and romantic beliefs crashed into those cold and indifferent physical laws of the universe and shattered. Or the atmospheres of planets are stripped away by radiation. Places we thought were oceans turn out to be acid lakes, and colors we thought were life signals turned into simple measurement errors. If that delicate balance necessary for life could be disrupted so easily even in our own solar system and around the most common star types, where was left in the sky that we could trust? Scientists pinned their hopes much further away, on those brand new and perfect systems harboring Earth-sized rocky planets around them. We believed that when we reached there, we would finally find the answers we were looking for. But new optical signals coming from the dark depths of space were about to confront the astronomy community with the biggest paradox to date. In those critical moments when the excitement of discovery peaked, every piece of data obtained proved how ruthless cosmic distances and optical blindness are instead of feeding hopes. As we analysed those weak light waves falling on the lenses of our space telescopes, we started colliding not only with the radiation danger of the stars, but also with the most fundamental limits of astrophysics. Our expectations were being crushed under the weight of freezing and cold equations. Even the planet that was applauded as the most Earth-like and promising candidate in the universe could not go beyond being an unreachable cosmic mirage in reality. When the space team led by astronomer John Jenkins found the planet Kepler 452b with Kepler telescope data in 2015, they declared a great victory, saying they had found Earth's older cousin. The planet was 60% larger than ours, its star was very similar to the Sun, and one of its years lasted 385 days. Everything was perfect, but this planet was 1,800 light-years away from us. Even if we travelled at the speed of light, it would take thousands of years to get there, and even the most advanced telescopes we had never possessed the optical capacity to confirm whether there was water on it. Even if there was liquid water on the surface of the planet, we had neither any physical technology to reach there nor a civilization lifespan long enough to wait for a radio signal to come from there. Our perfect twin remained locked as just a mathematical statistic in that freezing darkness of the universe. If we cannot reach that perfect twin across the ocean, we said we would look at our neighbour right under our noses. However, the universe played a ruthless optical game on us here as well. When Proxima b was first found, researchers assumed that they could easily analyze the thickness of its atmosphere, its water vapor, and chemical composition by watching the transit of this planet in front of its own star. However, in 2017, David Kipping from Columbia University and his team revealed that bitter truth as a result of their uninterrupted observations that lasted exactly 43 days, with the MOST telescope belonging to the Canadian Space Agency. The orbital plane of the planet was tilted according to our perspective from Earth, and the planet never passed in front of its star. Therefore, the light of the star could not filter through the atmosphere of the planet and reach us. Astronomers had to face that deep despair brought by not being able to solve the secrets of even a world that is our next-door neighbour, despite all the technological investment and advanced lenses. Our closest neighbour hid in an invisible optical blind spot where we could never analyse its atmosphere, even though it stood right in front of our space telescopes. On this map, where light reflections blinded us, when we turned the most powerful device we had to the most promising system, we hit a much harder physical wall. When those 7 planets in the TRAPPIST-1 system were discovered, astrobiologists thought that especially even the planets closest to the star could have some kind of protective thick atmosphere and perhaps clouds containing water vapor. Unfortunately, in 2023, when the team led by astronomer Thomas Green examined the system with the MIRI infrared camera of the $10 billion James Webb Space Telescope, all optimistic expectations collapsed. TRAPPIST-1b, which is the innermost planet of the system, had no protective atmosphere layer around it. Observations proved that the planet was just a bare and dead piece of rock, scorched by radiation, with a temperature of only 227 degrees Celsius. Our biggest hope had been completely scraped away by the merciless radiation of the universe, and only a pile of volcanic stone remained. This terrifying discovery slapped the world of astronomy in the face, with the fact that that very narrow, habitable zone around red dwarfs could essentially be an area of violent turbulence that destroys atmospheres. Despite all the disappointments experienced and the theories collapsing one after another, exoplanet hunters never gave up watching the sky. All these shocking crises we faced had essentially revealed how flawed and indirect our planet hunting methods were. If the universe does not give us the photograph of these planets directly, and if we cannot filter their atmospheres through the thick star glare, then how are we finding these hidden worlds? Detecting those small dark pieces of rock rotating in the orbit of a dim star billions of kilometers away was a mathematical struggle as difficult as tracing a matchstick going out in a dark ocean. The scientific world decided to turn one of the most sensitive physical laws of the universe in its favor precisely to overcome these optical crises. So how can we calculate the mass and orbit of a planet without ever seeing it? When you feel those thin metal ridges on the edge of a small coin you hold in your palm with your finger, you trust the microscopic sensitivity of your biological sense of touch. Or, whereas today, astronomers achieve a similar measurement sensitivity not with their own hands, but with optical lenses and spectrometers floating in the freezing vacuum of space. Weighing the mass and charting the courses of invisible masses light years away requires measuring complex systems beyond human perception, as if they were in our palm. The most successful planet hunting technique of modern astronomy is the transit, meaning passing in front of the star method. You can compare this optical mechanism to the shadow created by a small propeller plane flying in front of a powerful lighthouse, shining 10 kilometers away in the dark of the night. The plane momentarily blocks the light of the lighthouse, and that very short interruption tells us the size of the plane. Space telescopes also observe tens of thousands of stars simultaneously for weeks, and look for those microscopic drops in the brightness of the star at a rate of 0.01%. When a planet aligns directly with our telescope while rotating in the orbit of its own star, it blocks the light of the star at a certain period. When computer algorithms catch this regular dimming of light, astronomers calculate the physical diameter and the orbital duration in its own year of that invisible planet with a perfect mathematical certainty. This elegant light trap, which allowed the Kepler telescope to add thousands of new worlds to the astronomy catalogue, gives us the opportunity to make a complete inventory of the rock and gas giants in the universe. However, this optical method only gives the size, so we need another power to find the mass of that heavy dark object. The most fundamental tool used to understand the mass and density of the planet is the radial velocity, also known as the Doppler shift method. You can compare this to an adult holding their small child by the arms and spinning them round and round on a playground. The faster the child spins, the more the heavy adult's body wobbles backwards to hold onto the center. The situation in space is exactly the same. As the planet rotates around the star, it also slightly pulls the star towards itself with its gravity, and the star starts to wobble in the vacuum of space. Advanced spectrometers on Earth measure this wobbling movement of the star with an incredible sensitivity of 1 to 2 meters per second and detect the color shift in its light. When the star wobbles towards us, its light shifts to blue, and when it moves away, it shifts to red. When astronomers measure the intensity of this color fluctuation, they clearly decipher the exact mass and thus the structure of that planet. Being able to read this invisible tug of war is the sharpest astrophysical filter we have, especially to separate heavy Earth-like structures with the potential to harbor oceans from fake gas masses. While transit and radial velocity methods deal with the wavelength of light, the astrometry technique is the oldest and most challenging mechanism based directly on measuring the physical coordinate deviation of the star in the sky. It is possible to compare this difficulty to measuring how much a strand of hair of a person standing on the peak of a mountain 100 kilometers away is blown to the right or left in the wind. Even though the stars in the sky appear stationary from our perspective, they draw very small circular spirals on the celestial map due to the gravity exerted by the heavy planets in their orbits. Huge projects like the Gaia space mission map these tiny deviations by scanning the exact location of billions of stars with an unimaginable sensitivity that we call a micro-arc second. If a star draws millimetric curves instead of going in a straight line on the background of the sky, it means there is an invisible mass there. This arduous measurement gives us the chance to model the orbital inclination of the planet perfectly in space. This sensitive mechanism, which can detect orbital planes that other techniques remain blind to, is the most important cartographic tool that allows us to weave the three-dimensional wide mass map of our galaxy stitch by stitch. Beyond all these indirect mathematical games, the most challenging astronomical challenge is direct imaging technology. You can compare this mechanism to trying to see the fuselage of a passenger plane passing right next to the sun by blocking that intense blinding light with your thumb while looking at the sun at noon. A star in space is millions of times brighter than the planet around it and completely swallows that weak reflection. To solve this problem, microscopic optical masks called coronagraphs are placed inside the telescopes. These masks block the blinding light coming from the exact center of the star and make the region around it visible. When astronomers suppress the light of the star 10 million times in this way, the planet itself finally appears as a pale pixel on the telescope sensor. Those weak photons emitted by these planets whose light is captured directly offer us a first-hand and unmediated optical proof regarding chemical signatures in their atmospheres such as carbon, water, or methane. Today, space telescopes take these direct photographs and allow us to read even the heat emitted by those young and heavy gas masses hiding in the darkness of the universe through the color spectrum. While capturing the diameter, weight, orbital inclination, and the pale photons emitted by planets with these clever optical traps, the way we read the universe also changed irreversibly. Light curves and tiny shifts in wavelength stopped being cold numbers and turned into physical evidence drawing the geography of flesh and blood new worlds. However, all these devices, advanced lenses floating in the freezing vacuum of space, and million-dollar computers on Earth are not just theoretical tools explaining how these mechanisms work. The scientific world had to take these abstract astrophysical rules and transform them into extraordinary engineering marvels that would be the eyes and ears of humanity in the universe. So, where and how does that concrete technology, which takes these microscopic measurements and optical tricks out of theory and allows us to see those pale worlds in the depths of space with the naked eye, work on Earth today? Even though those elegant theoretical equations developed to measure cosmic distances look perfect on paper, they remain dysfunctional when you look at the sky through that thick and blurry atmosphere of Earth. Scientists realized they needed a wide eye that pushes the physical limits of engineering in order to capture those weak photons coming from the stars without interruption. This need gave birth to the most ambitious optical project in the history of humanity. The European Extremely Large Telescope, or ELT for short, is designed with a mechanism that will momentarily erase the atmospheric flaws of Earth in order to directly see those small planets rotating around the dim stars in space. When you look at the sky, you see the stars flickering or flashing. This romantic view is actually an optical distortion in our atmosphere and makes sensitive measurements impossible. The LT uses an aggressive technology called adaptive optics to eliminate this blur completely. Thousands of microscopic motors placed behind the large mirrors inside the telescope move exactly 1,000 times per second, momentarily bending and correcting the shape of the mirror according to atmospheric fluctuations. When the light reaches the sensor of the telescope, it becomes perfect and smooth as if Earth has no atmosphere at all. This mechanical bending process turns an optical illusion into reality, allowing us to display the biological traces in the atmospheres of distant star systems directly on the sensor. This groundbreaking marvel of technology is being built on the peak of the 3,000-meter Cerro Armazones mountain, located in the Atacama Desert in Chile, through the joint effort of hundreds of engineers and astrophysicists within the European Southern Observatory. This observatory, planned to become operational at full capacity in 2028, is a global gateway opening into the depths of space rather than an ordinary scientific facility. Since the foundations of the project were laid, optical experts coming from all over the world have spent years in these harsh climate conditions and developed unique algorithms for the alignment of the mirrors. The vision of the European Southern Observatory was not just to find new planets, but also to create a hardware that could directly capture their physical map. This mountain peak facility, which cost billions of euros to build and is managed by an international consortium, is counting the days to finally turn the visual sharpness scientists had only dreamed of until then into reality. This magnificent infrastructure is proof of how technological limits are redefined on that freezing desert peak. So, whose life does such a complex engineering marvel touch in practice? Think of that moment when an astronomer at the screen in that freezing darkness of the Atacama Desert sees the light of an Earth-like planet they have been searching for all their life without a filter for the first time. For astrobiologists who have been making planet predictions by only looking at indirect fluctuations for decades, the ELT is the moment blindness ends. Researchers who have put their careers on the line, had their papers rejected, or whose measurements were cancelled due to atmospheric errors to prove the existence of a planet until today, will now be able to present direct evidence with their own eyes. Scientists will stop being just researchers and turn into explorers drawing the map of new worlds. This telescope will radically change the way every person who looks at the night sky and asks if we are alone out there perceives the world, because the first clear image reflected from that lens will be a direct answer given to the cosmic loneliness of humanity. Even students making theoretical modelling in their laboratories will be able to verify their own theses instantly with the clear data offered by this device. The optical revolution created by this telescope finds its clearest expression in its terrifying physical numbers. The primary mirror located at the heart of the ELT is exactly 39 meters in diameter and consists of the combination of 798 separate hexagonal pieces with millimetric perfection. Thanks to this large surface area, the telescope can focus exactly 100 million times more light than the human eye can collect into a single point. Moreover, thanks to that aggressive optical system that eliminates atmospheric bending, it will take exactly 256 times sharper and clearer photographs than the famous Hubble Space Telescope in orbit. Standing stationary on Earth, unlike space telescopes, this 3,000-meter optical facility is an unrivaled observation power that simultaneously harbours the brute force and mathematical finesse required to rip those pale planets next to the stars out of the darkness. Every single square centimetre of this 39-metre primary mirror has been smoothed at the atomic level so as not to lose weak photons. These magnificent lenses built on those freezing peaks of Chile and the delicate mathematical algorithms that bring them to life are one of the most elegant victories the human mind has achieved. Thanks to this technological bridge extending from Earth to the sky, those alien planets that have been merely statistical shadows for years are finally getting ready to appear before us as physical worlds with their clouds and oceans. However, there is one more truth that all these devices, telescopes, and microscopic measurements show us. The architecture of the universe never conforms to the dimensions or durations we are accustomed to in daily life. The clearer the place we look at gets, the more overwhelming the size of the cosmic structures we encounter, and that terrifying weight of distances become. Let us now step out of the laboratories and lenses and look closely at how big a shockwave these distances and dimensions really create. No matter how sharply we see the universe with our large mirrors on Earth and advanced sensors in space, we're actually always looking at the ghosts of the past. Due to that limited speed of light, those pale photons that our telescopes capture today consist of cosmic echoes that set off years, even centuries before their targets. However, sometimes such a signal filters through these shadows of the past that we have to rewrite all current astrophysical rules and pessimistic equations at hand in a single second. For years, we had been accustomed to that pessimistic picture presented to us by our most advanced optical facilities. We believed that those very narrow habitable zones around red dwarfs were not life-giving oases, but rather deadly microwave ovens that ruthlessly tossed the atmospheres of planets into space. Astrobiologists were presenting definitive evidence that those furious and unstable youth phases of these dim stars, lasting billions of years, evaporated all kinds of gas layers and water in orbit, leaving behind only scorched bare pieces of rock. Those countless Earth-like planet candidates around red dwarfs, which make up 75% of the universe, had turned into merely statistical dead zones on paper. Those pessimistic theoretical models built for years were now cracking under the weight of a concrete physical observation. The scientific world was witnessing how that destructive radiation myth it created itself was left helpless in the face of the flexibility of the universe regarding survival. But in July 2026, a brand new paper that struck the heart of the astronomy world like lightning destroyed all these pessimistic equations overnight. This revolutionary research, published in the journal Science, finally presented to humanity that shocking evidence that would radically change the universe conception of not only space agencies, but every person looking at the sky with hope. The international science team led by Harvard University researcher Colin Cherubim was at the center of this historic turning point. So, instead of billion-dollar space telescopes, the team used the Magellan Clay Ground Telescope located on the high-altitude freezing peaks of Chile, along with a highly advanced spectrograph named WINERID integrated onto it. The target they focused on was a super-Earth-class rocky planet named LHS 1140b, rotating around a cold and dim red dwarf exactly 48 light-years away from us. This planet was a closed box that had been known to be in the habitable zone for years, but whether it had an atmosphere remained a great secret. Cherubim and his team captured that data, which was thought to be impossible, as a result of meticulous optical observations and infrared wavelength analyses that lasted for months. In those critical hours when the planet passed in front of its star, a certain wavelength of the weak starlight was absorbed around the planet and disappeared. This missing colour spectrum proved to astronomers a thin tail of helium gas, slowly leaking from the orbit of the planet into space, with an indisputable physical certainty. Until that day, such a clear and intact atmosphere trace had not been encountered on any rocky exoplanet. This presence of helium was not just the detection of a chemical element, but the optical signature of a cosmic resistance. The discovery of this helium armor floating around the planet LHS 1140b was literally a renaissance for astrobiology. Because this data was the first definitive scientific finding, proving that that planet managed to physically protect its own primitive atmosphere by braving violent star flares and scorching radiation storms lasting billions of years. The gravitational shield of the planet had not fallen, and the winds had not stolen its breath into space. Moreover, When the detected high physical density of the planet and this protective gas layer were combined, researchers reached a much more impressive conclusion. The probability of this super-Earth harboring deep global oceans on its surface, rather than a completely frozen layer of ice, was mathematically very high. The fact that those deadly zones around red dwarfs could host safe harbors covered with liquid water, contrary to what was thought, was finally proven. We now knew that even in that freezing and ruthless darkness of the universe, the water and air necessary for life to sprout could somehow be locked and hidden. This situation necessitated charting a brand new and much bolder route in the search for life. This unique discovery radically changed our perspective on those outcast planets rotating around trillions of dim stars in our galaxy, and opened a brand new door of hope that could end our loneliness in the universe. This possibility of a global ocean proven by the helium leak rekindled that romantic hunger we feel for space as humanity. Just think, only 48 light years away from us, a brand new world covered with liquid water and having a breathing thick atmosphere continues to spin silently in the freezing darkness of space. This news brought along that tempting but unfounded fiction in both the media and scientific circles in the form of saying we have finally found a second home we can go to. Thinking that these new worlds that our eyes can see, and our telescopes can touch optically, are right next door, and that we can easily reach them is a dangerous illusion stemming from our species forgetting its biological limits. So where does that ocean planet, which we toast to by calling it right under our noses, actually stand on a universal scale? When we attempt to go there physically, what is the real size of those overwhelming and incomprehensible cosmic distances that will stand in front of our ships made of metal and fuel, even though listening to these poetic astrophysical victories on paper flatters the arrogance of humanity? When it comes to sending concrete spacecraft to these planets, the cold equations of the universe show their ruthless face. Those bright pixels measured in centimeters behind telescope glasses correspond to physical abysses that our biological existence can never cross in the real world. While humanity thinks it is expanding the limits of the universe, it actually rediscovers how solid its own cage is. The human mind has evolved with a capacity to perceive kilometers on Earth or flight hours crossing continents. However, it is completely inadequate when it comes to comprehending universal units of measurement like light years. In order to grasp this overwhelming weight of distance, you need to look at that famous vehicle humanity sent into space, representing the most extreme point we have reached to date. The Voyager 1 spacecraft, which has been travelling at a mind-bending speed in the freezing vacuum of space for more than 40 years, is silently drifting at the outer limits of our solar system today, approximately 15 billion miles away from our planet. Even the weak signals it transmits to us take hours at the speed of light. However, that distance of 4.24 light years required to reach Proxima Centauri, the closest star in the universe that we assume is our next-door neighbour through news in the media, equates to approximately 25 trillion miles. That is, we have to go exactly 1,666 times deeper than that farthest limit that humanity has been able to reach with its own hands throughout its entire technological history. All those discoveries we proudly recount today saying we are pushing the limits of space are no different from merely stepping into knee-deep water on the shore of the dark cosmic sea. Our greatest record turns into a statistical nothingness in the face of the boundless vastness of the actual sea. This void created by physical distance turns into a much more terrifying abyss when the time factor comes into play. If you were to board a spaceship at the speed of Voyager 1, which is the fastest technology we have and travels kilometers per second, tomorrow morning, and set out towards that closest neighbor of ours, the Proxima Centauri system, it would take exactly 70,000 years for us to arrive there. This number may seem like a simple astronomical statistic. However, the true weight of this duration emerges when compared with the historical development of humanity. 70,000 years is equal to exactly 14 times the age of written human history, extending from the invention of the wheel to the construction of the pyramids, and from Sumerian tablets to the age of modern computers. Even the great-great-grandchildren of the astronauts who entered that ship will be born and die in the darkness of space without even completing 1% of the journey. Those hundreds of generations looking out the windows of the ship will never know the blue dot they left behind, and they will never see the new world they will reach. Perhaps they will turn into a lost metal tribe forgotten for thousands of years and exhausted by its own internal conflicts in that deep silence of space. With a crew that will be trapped inside that metal box for generations, civilizations on Earth will be destroyed and rebuilt many times until they reach the target star, and perhaps the human species will have long gone extinct. Interstellar travel is not a simple fuel problem, it is directly a cosmic time prison that mocks the biological lifespan of the human species. You must not forget that all these overwhelming statistics apply to our closest star neighbour in the universe. So, what happens if we turn to other famous targets it stares at with telescopes and which are heralded to harbour oceans? The 7-planet TRAPPIST-1 system, which is the most popular focal point of space agencies, is exactly 40 light-years away from us. This distance is exactly 9.5 times the abyss-like distance of that unreachable Proxima Centauri. The planet LHS 1140b, which shook the scientific world with its helium armor in recent months, is 48 light-years away, while the planet Kepler 186f, which the media enthusiastically presents as Earth's twin, is approximately 580 light-years away from us. You would have to repeat that Proxima journey, which we think is so far away and takes 70,000 years, exactly 137 times for the Kepler planet. As the numbers in our hands grow, our dreams of conquering space give way to a painful feeling of cosmic imprisonment. Let alone sending physical vehicles there, even analysing the pixels of the light beams those planets send us is a challenging game of patience that takes centuries. When those habitable zone promises that astronomers comfortably pronounce on paper crash into practical engineering limits, we face the fact of how tragically restricted the movement area of humanity in the universe essentially is. These incomprehensible distances of billions of miles and dark journey durations that swallow generations slap our true place in the universe in our face with all their weight. However, popular culture, the cinema industry, and click-oriented media headlines continue to draw a completely different universe portrait in our minds by constantly ignoring these harsh astrophysical rules. The second home good news appearing on screens every time a new planet is found, and the fantastic spaceship fictions exceeding the speed of light have created information pollution among the public that is diametrically opposed to the fundamental laws of astrophysics. Those exaggerated news stories, especially presented as if they sprang from science fiction novels, deeply prevent people from grasping the true dimensions of space and those freezing dangers it harbours. These false beliefs ingrained in our heads regarding space travel and the nature of exoplanets shadow not only scientific facts, but also the moral responsibility we should feel towards our own world. So what are the truths lying behind these popular space myths that we hear on televisions every day and believe unconditionally? We all grew up with those magnificent fictions on the silver screen, with those epic visions where brave astronauts jumped to alien systems with warp-driven ships, got off the ship, took off their helmets and took a comfortable breath. It was all. We assumed space was an area of conquest and the stars were new targets. However, in those cold laboratories where television screens are turned off and Hollywood's colourful filters are removed, the harsh mathematics of astrophysics writes a completely different reality. That abyss between fiction and truth is hidden in the popular myths destroyed by modern science. The most dangerous and most common first myth that comes to our minds when we read space news is this. When scientists announce they have found a planet in the habitable zone, we can land there with our spacecraft, take off our helmets, and take a deep breath, just as if we were in a forest. Or, at the root of this absurd vision lie those exaggerated headlines such as Earth's twin found or our second home in space, which the media throws by distorting scientific data for the sake of more circulation and clicks. People perceive the word habitable directly as a biological invitation. However, for the astronomy community, the concept of a habitable zone has absolutely nothing to do with green trees, blue oceans, or breathable air. This term consists only of a narrow thermodynamic orbital mathematics, where the distance of the planet to its star could theoretically allow water to remain in liquid form on the surface. This mathematical equation does not even guarantee that there is a rock layer on the surface of that planet that you can step solidly on. Its atmosphere could consist entirely of toxic sulfuric acid, or the pressure could crush human bones to dust in seconds. In short, the definition of a habitable zone in astrophysics does not offer us a tourist paradise where we can breathe comfortably, but only a cold physical boundary line where water does not boil. Stepping onto a planet in this zone does not mean descending into a cool valley full of oxygen. It most likely means dying instantly in a dark, suffocating, and completely alien geological hell. The second major illusion that popular culture has ingrained in our minds is related to the flow of time. There are planets around all stars in the universe that rotate on their own axis in 24 hours like our world, experience romantic sunrises and sunsets, and where seasons change. This illusion was born from the tendency of people to assume this biological rhythm they're accustomed to is a universal absolute truth, merely by looking at the planet rotations in our own solar system. In reality, the overwhelming majority of exoplanets we have found in the habitable zone and added to the catalogue to date are around dim red dwarf stars. These planets have to rotate so close to their stars to receive enough heat that they get caught in that ruthless physical trap called tidal locking. The strong gravitational force breaks the rotation of the planet around its own axis, and just as the Moon always shows its same face to Earth, the planet is locked to the star. The astrobiological result of this is a complete nightmare. While the face of the planet seeing the star experiences an endless and scorching day, the back face remaining in the dark experiences an eternal night and a freezing ice age. Clocks do not tick in most of the universe. Time is frozen forever, either at a hellish noon or a deadly midnight. That cycle of sleep and wakefulness we are accustomed to is not a universal rule, but only a luxurious coincidence unique to our system. The third deep myth is a false sense of security that emerges as the radiation danger of red dwarfs is frequently discussed. If we find a calm, stable, and yellow star like our Sun, instead of those dim red dwarfs around which deadly crises are experienced, the habitable planet around that star is completely safe, and life will definitely sprout there. This illusion feeds on the simplified narratives in the media of the perception that the structure of Sun-like stars is a perfect laboratory for biological evolution. However, new findings of the astronomy community have proven that even perfect twin stars located in the same spectrum as the Sun, such as Tau Ceti, harbour a major deadly surprise. Even though these calm stars do not make radiation bursts, they carry enormously large asteroid and comet debris disks in their orbits. That unfortunate planet sitting in the habitable zone, even if it has an ideal climate and balance, constantly remains under a heavy meteor bombardment raining from the sky. The waters on the surface boil constantly, and newly formed primitive biological molecules are destroyed over and over again in every collision. Or those friendly yellow stars that look perfect turn their planets not into an oven scorched by radiation, but into a ruthless cosmic shooting range that never gives life a chance to flourish. Therefore, every time we think we've found an absolutely safe harbour in the universe, a destruction mechanism with a different dynamic comes into play and manages to shake astrobiological expectations to their core. This violent reality of space shatters not only the atmospheres and orbits that will feed life, but also the physical fictions we will make there. Even though those poetic forests where we could take off our helmets and comfortably set up camp, those long days that do not end, and calm worlds not visited by asteroids look nice on fiction shelves, the science of astrophysics forcibly wakes us up from this romantic dream. However, popular space myths are not limited to these. The illusions the science fiction industry has left us as an inheritance contain very deep mistakes not only about the nature of the planets we find, but also about how we will go there and the gravity of the planet there. We will continue to destroy those bright hopes of civilization that definitely take place in the mind of every person who looks at the night sky and dreams. So, what unexpected biological nightmares actually await us when we step onto those smooth exoplanets that the media makes us believe are physical copies of Earth? An orbit with the possibility of liquid water on its surface is just the beginning of the obstacles we must overcome to survive. Even though the presence of water makes us feel safe, the very first second we step onto the ground of that planet, we collide with the most ruthless of our universal illusions. While we watch astronauts running and walking comfortably just like on their own planet in every new world they find in fiction movies, we somehow always ignore harsh astrophysical laws like mass and density. From here, we reach the fourth major myth. If the diameter and volume of an exoplanet are millimetrically the same as Earth, the gravity of that planet must also be the same as ours. This myth feeds on the fact that the concept of volume, meaning physical size, and the concepts of internal mass and density are confused as synonymous with each other among the public. However, the geological chemistry of the universe does not shape according to our simple expectations. Even if the equatorial diameter and outward appearance of a planet are a perfect copy of Earth, if the density of iron, nickel, or other heavy metals in the core of that planet is much higher than ours, the gravity on its surface increases exponentially. Imagine stepping onto a twin planet with such a heavy core. The moment you land on the surface, you would be glued to the ground with 3 or 4 times your own body weight. Your blood could not be pumped to your brain, your kneecaps could not withstand this pressure and would break within seconds, and your biological body would be ruthlessly crushed under that overwhelming violence of its own weight. While you dream of from here, we reach the fourth major myth. If the diameter and volume of an exoplanet are millimetrically the same as Earth, the gravity of that planet must also be the same as ours. This myth feeds on the fact that the concept of volume, meaning physical size, and the concepts of internal mass and density are confused as synonymous with each other among the public. However, the geological chemistry of the universe does not shape according to our simple expectations. Even if the equatorial diameter and outward appearance of a planet are a perfect copy of Earth, if the density of iron, nickel, or other heavy metals in the core of that planet is much higher than ours, the gravity on its surface increases exponentially. Imagine stepping onto a twin planet with such a heavy core. The moment you land on the surface, you would be glued to the ground with 3 or 4 times your own body weight. Your blood could not be pumped to your brain, your kneecaps could not withstand this pressure and would break within seconds, and your biological body would be ruthlessly crushed under that overwhelming violence of its own weight. While you dream of walking on a new world, your blood flow stops and that planet merely turns into a dark tomb for your biological existence. These planets of the same size are not comfortable continents where astronauts can plant flags. On the contrary, they are invisible gravitational vices that will instantly tear human anatomy apart. Those fancy Earth-sized planets found headlines of the media never take this geological density trap that will crush your bones to dust in practice into account. The fifth common false belief is one of the biggest optical illusions of the information age. The delusion that we can directly photograph the surfaces, continents, forests, and blue oceans of these exoplanets with our telescopes and see them in high resolutions. Those detailed, cloudy, and colourful planet visuals shared with the logos of space agencies on news websites and social media are thought to be real optical photographs due to the ignorance in the media. However, none of those visuals are real. They're artistic illustrations that institutions like NASA or ESA have digital graphic artists draw specifically for press releases to attract more attention. Despite all those billion-dollar investments in direct imaging technology, the real data we have is far from a visual feast. Astrophysicists can never see these new worlds with surface detail. They read them on computer screens only as numerical drops consisting of a tiny transit dimming of 1 in 10,000 in the light of the star or wavy lines on a radial velocity graph. That magic lens that will combine those photons coming from billions of kilometers away and lay them before our eyes has not been invented yet, and according to the laws of physical optics, its invention is close to impossible. Dazzling ocean waves or green continental borders are actually a fictional product of imagination born not from lenses, but only from the computer software of artists. Even the clearest direct photograph that our most advanced optical devices can capture consists of a single pale, shapeless and blurry pixel shining on a dark background. The sixth, and perhaps the myth that challenges astrobiology the most, is built upon the meaning of atmospheric gases. If we find oxygen gas in the atmosphere of a distant planet, it means there are photosynthesizing plants, trees, or biological alien life there. This illusion stems from assuming that the fact that the oxygen we breathe on Earth is produced by plants is a universal rule. However, the chemistry laboratory of the universe harbors much more ruthless and deceptive processes. When a planet in its early stages is exposed to extreme radiation storms coming from its own star, all the ocean waters on the surface boil and evaporate. This large mass of water vapor rising into the atmosphere is broken apart by the violent ultraviolet rays of the star through a physical process called photolysis. While the lighter hydrogen gas escapes gravity and flees into space, millions of tons of unreacted, biologically completely lifeless and dead oxygen are left behind. That intense oxygen signature that scientists will see when they look through a telescope is not the breath of a green and living forest. On the contrary, it is the chemical corpse of a destructive murder where all the waters of that planet were boiled and destroyed. Therefore, the first oxygen molecule that our telescopes will catch on spectrum maps may not represent the cosmic victory of life, but quite the contrary, that sterile and deadly void left behind by starstorms. All these common false beliefs, that overwhelming force of gravity, our blindness at the pixel level, and the deceptive chemistry of oxygen ruthlessly prove what a tough road the space race is progressing on. As that easy and comfortable universe picture that science fiction movies promise us collapses, only that cold, unforgiving face of mathematics, optical engineering, and gravity equations remains. Despite this, the astronomy world has not surrendered to this pessimistic picture. On the contrary, as we realize our illusions, we are preparing to launch the most complex, most expensive, and most daring devices in human history into the freezing vacuum of space in order to overcome these optical and chemical tricks of the universe. Since we cannot see planets directly, since oxygen deceives us, and since we cannot go there within our own lifespans, then what does that next generation technological arsenal of ours that will tear down these walls of the universe contain? What radical methods will these advanced devices, which will be launched into orbit in the near future, use in order to solve the secrets of the galaxy? Our biological limits may have imprisoned us on Earth, and the laws of physics may have practically forbidden us from reaching the stars. However, instead of surrendering to these pessimistic walls erected by the universe, human engineering has chosen to drill microscopic holes in those walls. So, since we cannot send our bodies to those distant planets, then we have to deploy our most aggressive and radical technological weapons in the history of astronomy that will carry our eyes and perception light years away. Otherwise, we would have to settle for only shadows in a dark room. Today, the deadliest and sharpest weapon of our optical arsenal in space is undoubtedly the James Webb Space Telescope. This technological masterpiece is not just an ordinary mirror collecting the light of stars. It is a revolutionary analysis laboratory capable of reading infrared waves in the coldest corners of the universe. Thanks to the ENIAC and MIRI instruments it houses, it tears apart the wavelengths filtering through the atmosphere of a planet, passing in front of its star with a sensitivity no device has reached before. In the last 6 months, data coming from this telescope has created the harshest turning points in the history of astronomy. When Thomas Green and his team turned the MIRI device to the TRAPPIST-1b planet and measured the thermal emission of that world, they proved within seconds that the planet had no heat distribution and was a bare rock completely devoid of an atmosphere. Right after that, in July 2026, Colin Cherubim's team combined their observations in Chile with Webb data and discovered that helium layer leaking into space from the planet LHS 1140b. James Webb is not just binoculars looking for planets for us. It is our most powerful astrophysical detective that grabs invisible atmospheres light years away by the throat and ruthlessly rips their secrets out. The infrared eyes of this device laid both the hopes and disasters hiding behind those freezing gas and dust clouds of the universe before us on such a naked and clear frequency for the first time. But the appetite of astrophysicists is not satisfied with measuring indirect transit passages. They are planning a much sharper optical revolution that will pull those invisible worlds out of the darkness. The Habitable Worlds Observatory, which is targeted to be launched into orbit in the 2040s, is a concrete product of this radical ambition. This project completely rejects a passive method like waiting for the planet to pass in front of the star. Its goal is to directly choke and mask the blinding light of the star at the level of optical pixels. For this, a coronagraph mechanism of unprecedented sensitivity will be placed at the heart of the telescope. This technological mask will optically cancel that overwhelming glare of the scorching star from the center and only allow the reflective, pale planets orbiting around it to fall directly onto the camera. Thanks to this space-based optical filtering, which no device on Earth has been able to achieve, direct photographs of Earth-like rocky systems hidden behind the star glare will be able to be taken. Moreover, oxygen and water traces in the light spectrum of these pale dots will be personally torn apart and separated. With this complex hardware, the scientific world aims to put an end to those deceptive light games of the universe and hunt hidden worlds with physical evidence that leaves no room for doubt. When this project comes to life, we will have seen the true portraits of our neighbours hiding in those dark waters in the universe with our own eyes for the first time. If we see those planets optically, we also had to find a brand new and crazy way to reach there physically. This is exactly why the Breakthrough Starshot initiative was born, to shatter this deadlock. Aiming to reduce that devastating journey time to the nearest star with traditional rocket fuels from 70,000 years to just 20 years, this project is the most extreme propulsion system in the history of engineering. The idea is to produce nanospacecraft weighing only a few grams and the size of a chip, instead of building huge spaceships. After these microscopic sails are released into Earth orbit, laser arrays of incredible power built on Earth or in space will be activated. Hundreds of laser beams will focus on these light sails simultaneously, applying enormous photon pressure to those nanochips in just seconds. Thanks to this pure pushing power of light, the vehicles will theoretically accelerate up to 20% of the speed of light and be launched into the freezing vacuum of space. This means the end of the clumsy space race based on rocket equations and fuel tanks. Humanity has already decided to load its mind and silicon chips onto the back of laser beams and launch them into the universe in order to protect its biological body from those hellish distances. When those chips transmit those unique pixels they capture, while passing by our close neighbour Proxima to Earth, at the end of this journey that will take 20 years, the era of interstellar travel will have directly begun. This technological ambition, ranging from microscopic sailboats, pushed by lasers, to space telescopes blocking the light of stars, is actually the strongest challenge we throw at the universe. Thanks to these weapons we have developed, we can now read helium leaks floating in those distant atmospheres, prove the lack of water vapour, and millimetrically measure the destruction created by stellar winds. Even those dangerous habitable zones around red dwarfs ceased to be an unsolvable wall for us, and turned into analysable data sets. However, no matter how aggressive our technology gets, much deeper astrobiological unknowns that even telescopes or lasers cannot easily figure out continue to appear before scientists. As we cross boundaries with the optical power of our devices, the universe increases the difficulty level of the questions it asks us at the same rate. So despite us advancing this much technologically, what exactly are those unsolvable space mysteries that make even the brightest astrophysicists lose sleep in laboratories today? Despite all those next-generation detectors and large mirrors we have, the universe continues to produce biological and chemical illusions so as not to hand over its secrets easily. These open mysteries shaking the foundation of astrobiology stem not from the inadequacy of our devices, but entirely on the contrary, from the physics and chemistry in the universe being much more deceptive than we can comprehend. The data we capture with our new technologies are dangerous scientific gambling tables we have to bet on, rather than solved answers. The first major deadlock taking place at the centre of those heated debates in laboratories is the mystery of climate collapse created by tidal locking syndrome. Or, as we know, one face of those red dwarf planets rotating close to the star in the habitable zone has to experience an endless and scorching day, and the back face a freezing night. This stable physical state is a physically proven phenomenon, but what is unknown is whether the atmospheric winds and ocean currents on that planet can carry the heat on the scorched bright surface to the freezing night. Can the thick atmosphere evaporating on the day side freeze completely from extreme cold the moment it passes to the night side and collapse onto the ground? The bet is quite high. If this atmospheric collapse theory is correct and heat cannot distribute, no liquid water can exist on either the bright side or the twilight zone of these worlds, and the system collapses. The answer to this question is a matter of life and death for astrobiologists. If winds cannot build a bridge between these extremes, billions of promising candidates and catalogues are just icy tombs. Today, climate scientists within the NASA Goddard Institute for Space Studies work computers day and night to solve this freezing mystery through the climate simulations of these planets, using the rock three-dimensional general circulation models they developed. These vast data simulations are the only ray of hope humanity has to predict whether a distant atmosphere will collapse or not. The second major knot is the mystery of the origin and resilience of water that threatens our ocean planet's fantasy. When astrobiologists calculate the distance of a planet to its star, they prove that it fits the habitable zone mathematics. Optical distance supports that fine line between water freezing or evaporating. But the unknown dark spot is whether that planet harbored any water on its surface during its formation stage. Could those violent volcanic conditions in the early stage and those violent radiation bursts when the star was first born have already evaporated all the primitive waters on the planet and swept them into space? The bet is this: if water cannot survive the hottest youth years of the planet, no world that telescopes declare habitable today, just by looking at orbital distance, can be considered a safe harbour. If there is no water, those perfect orbital curves have no biological value. To break this vital unknown, ALMA radio telescope teams operated by the European Southern Observatory in Chile have stepped in. They are trying to decipher directly with optical data how and under what conditions waters were carried to planets by physically searching for the distribution traces of water glaciers inside newly forming gas and dust disks around distant stars. If we cannot solve the mathematics of water surviving that fiery birth phase, we are doomed to map the universe merely as an empty and arid desert. The third and most mind-gnawing deadlock is the mystery of remote life signature forgery. In the first layer, when we detect oxygen, methane, or phosphine in an atmosphere light years away with spectroscopy devices, we experience the crisis of knowing whether this definitely belongs to a living entity. It is indisputably proven that these gases leave measurable color barcodes and traces on the spectroscopy screen. However, that unknown dark possibility is this: could completely lifeless volcanic, geological, or ultraviolet chemical reactions be producing these chemicals in large proportions, rather than organic plants or bacteria? If abiotic, meaning lifeless processes, can produce oxygen in large proportions through photolysis, for example, we have to conclude that the universe constantly deceives us regarding biological life. In this case, any biosignature data we obtain will always remain suspicious, and no spectroscopy analysis will ever be able to offer us that absolute and final proof we seek regarding the existence of life. In order to sort out these deceptive fake signatures, laboratory researchers in centres like the NASA Astrobiology Institute and the Earth Life Science Institute are trying to break these chemical lies of the stars by developing lifeless abiotic gas evolution simulations and photochemistry models. In other words, scientists are practically playing a chemical detective game to learn whether a lifeless rock can coincidentally imitate a breathing forest. The swirling storms on the screens of rock simulations, the lost glacier traces the ALMA telescope looks for, and these fake chemical signatures astrobiologists wrestle with have proven to us all what a stubborn and impassable structure the universe has. While these fierce mathematical and chemical wars going on in laboratories try to tear down those cold physical barriers of space, they also redraw the boundaries of the human soul at the same time. Because these unreachable depths of space and that incomprehensible eternal silence have deeply shaped not only astrophysicists at the computer, but also artists, philosophers, writers, and biologists throughout history. How did this infinite darkness, which we can never reach mathematically and whose chemistry we are incapable of reading clearly, manage to leak into our mythologies, literary fictions, and existential fears? Let us put aside the cold lenses of telescopes for a moment and look at how this overwhelming physical reality of the universe echoes in human culture and art. We are trying to challenge that cold darkness billions of light years wide, dark galaxy clusters, and star storms by launching microscopic chips. However, when we turn our eyes from this overwhelming vastness of the macro-universe to inside ourselves, to that fragile micro-universe of the human mind, the scenery changes completely. This silent vastness of space has shattered not only rocket engineering, but also that deep psychological perception of ours that questions who we are. Every new distance telescopes reach is an existential crisis trigger that deepens the cosmic loneliness in our souls even more. Throughout human history, our civilizations have been built upon that comfortable, anthropocentric arrogance where we saw ourselves at the perfect and privileged center of the universe. Every time we looked at the sky for centuries, we believed that those shining lights were merely decorative dome ornaments created just to illuminate our world. But as the lenses of modern astrophysics added brand new exoplanets to the catalogues of our Planet Hunter satellites every day, this mythological and philosophical centrism was ruthlessly destroyed. It was mathematically proven that that blue home of ours, which we thought was unique and the only one, is just an ordinary dusty planet on a universal scale, with statistically billions of copies that no star cares about. The human mind had to face this deep shock created by losing that feeling of divine privilege it created itself. The fact that we are not special in our own universe created deep fault lines in every field from philosophy to theology and from sociology to art. The idea that our biological existence is a cosmic coincidence and our world is a temporary piece of wood drifting in the universal ocean became one of the heaviest psychological traumas settled in the subconscious of modern humans. Every new planet catalogue published in cold blood by astronomers is actually a new nail driven into the coffin of human arrogance. While we were mapping the universe with those large telescopes, we were looking into that bitter mirror showing how spiritually small and insignificant we are. This statistical abundance that crushed our egos paradoxically intensified that eerie cosmic loneliness in the human soul even more. We know that there are billions of potential ocean worlds like ours in the sky. However, no intelligent technological signal, a sound or a flash of light comes from any of those worlds. This chilling picture, called the Great Silence in astrophysics, has given birth to cosmic solipsism in philosophy, meaning the feeling that we are all alone in the universe. Just like everyone falling silent in a crowded room and looking only at you, the universe silently looking towards us with its billions of planets creates an unbearable pressure on human psychology. As a social species, we are looking for echoes that will talk to us and confirm our own existence in the universal darkness. However, only the static noise of the stars and the rustle of dead chemical reactions return from that infinite vacuum of space that our radio telescopes listen to. This unresponsiveness has dragged artists and thinkers into that dark vortex of the question, are we alone in the universe, or is everyone around us long gone? This silence slaps in our faces the fact that the friendship messages humanity launched into the universe are essentially desperate screams thrown into an infinite void. For philosophers, this situation is that painful moment of philosophical awakening, where our species completes its biological adolescence and faces that cold and indifferent face of the universe as an adult for the first time rather than a physical measurement. This existential crushing of the human mind and its inability to accept the universal silence naturally found its own way out in literature and the art of science fiction. When geniuses like Arthur C. Clarke or Isaac Asimov sat down at their keyboards, they were not just fictionalizing metal spaceships or laser weapons. They were directly pouring that dark melancholy created by this cosmic loneliness and incomprehensible distances onto paper. Those golden age works of science fiction literature were actually artistic shields created by humanity to hide its helplessness in space. Writers tried to comfort human psychology by crossing those scorching red dwarf hells and those unreachable light-year distances presented to us by telescopes with fictional warp drives or wormholes. Art stepped in to protect the human soul against that ruthless and cold mathematical reality of science. The galactic empires in the novels we read today and those crowded alien bars in the movies we watch are are hopeful hallucinations produced by our brains wanting to reject that freezing and deadly reality of the universe. By turning space into a playground, artists essentially tried to defeat that terrible silence and this small blue cage in which the laws of physics imprisoned us in their own minds. Therefore, science fiction masterpieces are philosophical rebellion letters written by humanity against that boundless darkness, rather than technical predictions. While real astronomy crushes us, literature allows us to stand back up from under that wreckage. These sheltered havens built by literature and philosophy are our psychological survival mechanisms in the cosmic arena. As humanity felt how weak and alone it was on a universal scale, it clung to art and philosophy with greater violence and continued to search for its own soul in that deceptive light of the stars. Every single blurry pixel taken by those giant telescopes reflects not only the chemical composition of a brand new planet, but also that never-ending search for belonging within us. However, even these rebellious and hopeful fictions of art cannot surpass the effect created by that single and unique photograph frame presented to us by scientists from time to time. We have an optical heritage much more powerful and much more staggering than all the novels we have written, and all the fictional empires we have established throughout history. So what is that famous historic turning point that summarizes humanity's place in the universe much more sharply and much more ruthlessly than all those philosophical debates and literary works? This historic confrontation, which pierced the consolations offered by literature and those abstract shields of philosophy, came from the viewfinder of a billion-dollar spacecraft. What delivered the final blow to human arrogance was not a philosophical manifesto written pages long, but a simple and ruthless camera lens with which we looked back at our own planet in the freezing vacuum of space. That single photograph frame, which deeply shaped the soul of modern astronomy, is the clearest optical proof of our existential helplessness. The architect of this cosmic enlightenment is the astrophysicist and thinker Carl Sagan. In 1990, the Voyager 1 spacecraft had reached the borders of the solar system and was getting ready to set off towards a dark, unknown void. While NASA engineers were planning to permanently turn off the cameras and transfer the power of the vehicle to other instruments, Sagan put forward an extremely radical and visionary idea. The vehicle had to be commanded to turn its cameras backward to the direction it came from for one last time. From a scientific point of view, it was obvious that this frame would not provide any new astrophysical data. Some bureaucrats even strongly opposed this idea, on the grounds that that scorching light of the sun could burn the lenses and break the system. However, Sagan's main goal was not to study the geology of the planets, but to capture an optical slap frame that would crush that never-ending philosophical arrogance of humanity. After long debates, the command was sent, and the vehicle looked back towards its own orbit for the last time from 6 billion kilometers away. When those noisy, low-resolution digital data packets that arrived were combined on laboratory screens, that famous frame emerged that would eternally change not only the astronomy world, but also humanity's perception of universal belonging, the pale blue dot. That frame was a unique psychological mirror that slapped in our faces how alone and vulnerable we are in the cosmic arena, lost in the vast darkness of the stars. For the first time in the history of astrophysics, a spacecraft was used not to explore, but purely to put humanity in its place. When you look at this legendary photograph frame, you do not see giant galaxies or spiral nebula. You only see a single, dull and faint blue pixel suspended within a sunbeam hitting the viewfinder of the camera. So, that tiny glimmer is the sum of everything upon which our universal arrogance is built. As Carl Sagan summarized with those unforgettable words, all the kings, peasants, dictators, lovers, philosophers, and scientists who lived throughout human history lived and died on that 1 millimeter blue dust speck. All the blood spilled, those great victories thought to be won, and all the empires established were done just to momentarily rule a small corner of that faint pixel. In that chilling and indifferent silence of the macrocosmos, this piece of rock we call Earth is an ordinary boat with no privileges drifting all alone in the ruthless ocean of space. That photograph ruthlessly slaps in our faces that saviors will not descend from above, and that there is no divine or technological power to protect us from that freezing darkness of the universe. Humanity is a cosmic orphan left alone only with its own species in this absolute darkness, with no philosophical alternative other than clinging to one another. This deeply poetic text by Carl Sagan proved that astronomy is not a cold engineering branch, just calculating distant stars, but a staggering mirror that descends directly to the center of human existence. This existential shock created by the pale blue dot is also the greatest philosophical and moral compass of all that modern exoplanet hunting we conduct today. While discussing the probability of the planet LHS 1140b harboring oceans in 2026 or tearing apart new atmospheres with James Webb, we are actually looking for other pale blue dots in the sky. We are trying to rebuild the hope we lost on our own horizon, on those faint pixels rotating around those dim red dwarfs, trillions of kilometers away. However, this technological hunting also brings a terrifying moral dilemma with it. Constantly marketing habitable exoplanet news in the media with the label of our second home philosophically legitimizes humanity's tendency to recklessly destroy the only home it has, namely Earth. The illusion that there is a brand new ocean planet to go to is a cosmic excuse we fabricated to escape the responsibility of protecting our own blue dot. We must not forget that those tough equations and insurmountable tidal lockings have proven a universal truth to us. The universe is not a perfect hotel designed for the biological continuation of our species. We have no other shelter in our hands but a single pixel suspended in that freezing vacuum of space, which we have to protect and keep alive. Therefore, while turning our telescopes to the most remote corners of the galaxy, we must accept that what we are essentially looking for is not salvation out there, but a final confirmation of this unique and fragile loneliness of ours in the universe. The limitations of our biological structure, the inadequacy of our optical tools, the tendency of universal chemistry to deceive us, and that overwhelming philosophical loneliness created by distances of billions of light years. When we put all these facts together, we see that exoplanet hunting is a cosmic imprisonment experience rather than a romantic space conquest. Those scorched rocks rotating around red dwarf stars and those ocean planets locked in eternal night are far from being ports of salvation for us. Every new piece of data astronomers obtain from those pale pixels tears apart that fake feeling of safety in science fiction movies a little more and forces us to face those cold, silent and unforgiving equations of space. So, how can we summarize humanity's place in the universe and those deceptive exoplanet dreams of ours in the light of all these harsh realities of astronomy? After so much refuted fiction and technological disappointment, what is the final scientific legacy remaining when we fix our eyes on the sky one more time? That hope-filled desire for conquest we feel every time we look at the sky gives way to a deep existential chill when it crashes into the ruthless and cold walls of the universe. While we live with the dream of those easy and comfortable space travels promised by fiction movies, real astronomy has slapped in our faces how fragile and alone we are in the cosmic ocean. When the light of the stars reached us, we felt in all its nakedness in what a distant and unreachable darkness we are actually trapped. Within all this feeling of helplessness, that unprecedented discovery that went down in astronomy history became the only branch of hope astrobiologists clung to in the dark. That unique super-Earth, which did not bow to the deadly radiation storms of red dwarf stars and managed to protect its primitive atmosphere and deep oceans for billions of years with the helium shield it leaked, proved that infinite stubbornness of the universe regarding survival. This biological resistance in space whispers to us that hidden worlds resisting in the middle of darkness exist, no matter how inadequate the technological limits of humanity are. When you too look at the night sky and dive into those countless shining stars, you now know much better that they're not just romantic points of light, but unreachable physical distances and tough tidal lockings. As you think about the invisible disasters lying behind those distant atmospheres and the ruthless silence of space, you will realize what a sheltered cage we are actually in. When you imagine those dark waters telescopes cannot see, you will feel this unique loneliness of ours in the universe to your very cells, and understand that cosmic value of every step you take on Earth once again. If this freezing and realistic face of the universe has opened new philosophical horizons in your mind, do not neglect to like the video and share your thoughts with us in the comments to discuss those unsolvable mysteries of space. You can also ensure that a space enthusiast friend of yours like you, who is interested in that harsh and staggering reality of science, joins our science family by sending this video to them immediately. So, from which corner of the world, from which city are you watching me right now while discussing this overwhelming loneliness of space? Let's definitely meet in the comments. While we sadly talk about how even going to our own star neighbours will take tens of thousands of years, that great astrophysical picture that is the actual terrifying one has not even hit us in the face yet. While we struggle to perceive even the boundless vastness of our own galaxy, the Milky Way is this magnificent galaxy we think is huge, merely a single drop of water that fell into the ocean on the map of the expanding universe. We have just learned that desperate loneliness of interplanetary distances and the dark face of tidal lockings. However, even the hundreds of billions of star systems in the Milky Way are just a microscopic speck next to the trillions of galaxies of the observable cosmic web. That home we think is boundless is nothing but an invisible dust speck lost within frightening dark currents. So how big is the entire universe really compared to our galaxy? Are you ready for the new cosmic shock?